Okay, so now let's move on to question number 13. How would you determine the empirical and molecular formula for hydrogen peroxide, which is 5.94% hydrogen and 94.06% oxygen, and it also has a molar mass of 34.01 grams per mole? Okay, so this is a multi-step question. But before I do any math, I'm first going to make the assumption that there is 100 grams of hydrogen peroxide. Okay, so this makes calculations much easier since they give us percentage values. So for example, step 1, let's say we had the mass of hydrogen over the total mass of hydrogen peroxide times 100%. The question told us that this should be equal to 5.94% hydrogen. So if I assume that there's 100 grams of hydrogen peroxide, if I were to sub that value in for our total mass, so I'm just going to erase this and actually write out, let's say it was 100 grams. Then I can just say that therefore there is 5.94 grams of hydrogen in a 100 gram sample of hydrogen peroxide. So now that I know the mass of hydrogen, I can calculate the number of moles of hydrogen as well. So to do that, number of moles is equal to mass over molar mass. We calculated the mass to be 5.94 grams, and the molar mass of hydrogen is just what you would find on your periodic table, and it's 1.01 grams per mole. So now let's do the math, and you'll notice that our grams should cancel out, and we're left with a value in moles, and you just get 5.89 moles of hydrogen. So let's do the same thing for oxygen. It's 94.06% oxygen. So then I can just simply say that the mass of oxygen, if it was in a 100 gram sample of hydrogen peroxide, it is 94.06 grams. So now I can calculate the number of moles of oxygen. So it's just 94.06 grams divided by the molar mass of oxygen, which is just 16. And you end up getting 5.88 moles. So those are the first two steps. The third step is to divide by the smallest number of moles. So I'm going to write out hydrogen. It was 5.89 moles divided by basically almost the same thing, 5.88. I'm going to show to do the same thing for oxygen. And we get an empirical formula of H1O1. So let me just label that this is our empirical formula. So since they told us already what the molar mass of hydrogen peroxide is, this brings us to step 4, which is just to find the ratio of the molar masses. So the formula weight of H1O1 is just the same thing as the molar masses of hydrogen and oxygen added together. So I'm just going to write just like a small thing here. Molar mass of HO is just 17.01 grams per mole. So this was adding up the 16 and 1.01. So to find the ratio of the masses, if we know that the molar mass of hydrogen peroxide is 34.01 grams per mole, and the formula weight of H1O1 is the 17.01, the ratio is around 1.99, or we can just say that it is 2. So this brings us to the last step, which is just writing out the molecular formula. So let's start off with our empirical. I'm going to multiply the whole thing by 2, and you end up getting our formula for hydrogen peroxide, which is H2O2. So this is our molecular formula. Okay, so let's see what our junior tutor said. Empirical formula is the simplest whole number ratio of the various types of atoms in a compound. So to get the whole number ratio, we must get the number of moles of H and O in the compound. So they also assumed that you had 100 grams of hydrogen peroxide. So they just did it all in one step, but they got the same number of moles. The next thing is to divide by the smaller value of moles, which was the 5.88, and they got an empirical formula of HO. To get the molecular formula, I need to determine the ratio between the formula weight and the empirical formula. So they actually showed out how to get the 17.01, and they got a ratio of 2. So the solution is correct.